And with that, I would like to move on to our final speaker, who is Chris Knoop. And I just want to check, Chris, you are there?
I am here.
Very good. If you would like to request control, if you are going to be advancing your own slides, while I just give you a short introduction here. So Chris is joining us, as I mentioned. He was the designated dinner speaker for the STS AICHE dinner, which was supposed to be taking place today. So his topic is not identical to what we've been talking about with resilience and lessons learned from Harvey, but I do believe what he has to say is something that will be of interest to everyone on the call, anyone involved in energy management and greenhouse gas emissions especially. So Chris is CEO of Carbon Sequestration, Inc., and also an active partner with timber management groups and timber owners in the American South, with an interest in reducing global CO2 levels. He's also a lawyer, so for those of us who are engineers, don't be too scared. I've talked to him and he's a nice guy. He has oil and gas experience, including energy contract litigation work, and he is owner of the Knoop law firm and president of Bankers Oil Corporation. He has a JD from South Texas College of Law and a BA from the University of Texas at Austin. And so, Chris, without further ado, I'll hand over to you.
Thank you, Alan, and thank you, members of the AICHE. Special shout out to Tom Rein, an AICHE fellow and also the founding member of the local climate solutions community. And we look forward to working with him later this year. One thing about me, I'm, as Alan said, I'm an attorney, and I'm very invested in the oil and gas side of things. So when people find out that I'm doing carbon sequestration, they don't know how to respond. They might think that I'm somehow adverse to the oil and gas industry and that I'm now an environmental proponent. But at the end of the day, what I've stumbled across is a potential new industry for Houston, Texas, and for this country. And it's something that the former president of Shell, John Hofmeister, has been speaking about since the mid-2000s, and also Lee Raymond, the CEO, former CEO of Exxon, which is that as an industry, if we are going to treat CO2 emissions as pollution, we need a price on that CO2 so that we can continue our profit-making activities. And in the past year, essentially, a price on carbon has started to emerge. And I'll get into that in a little bit. But again, thank you for your time listening to me. And I will try to tie this into Hurricane Harvey at the end. All right, let's get started. Well, I'd like to, while Alan is working on that, say a few things of why Houston is a great place for this new industry. And we've become very effective with the shale revolution at taking carbon out of the ground. And it would make sense that the specialists that take it out of the ground are the ones that pioneer getting it back into the ground.
Okay, you ready to move forward?
Okay, so let's get started. Professor Ning Zhang has been very generous with his time, talking with me about these ideas. He is the inventor of a sequestration technique, which is taking wood and burying it. It's as simple as it gets. And you can see from the diagram here that Professor Zhang, who is the chair, University of Maryland, Department of Atmospheric and Oceanic Science, the idea by Professor Zhang is simply to manage forests more actively. All the chemical engineers here, or some of you probably know the composition of trees and biomass. And until recently, I didn't. Trees are, from my understanding, mostly air. And the dense wood is approximately 50% carbon. So going back to the periodic table, the carbon weighs 14 and the 2 oxygen weighs 16. And so the conversion of carbon, or the degradation of carbon into CO2, results in a molecular weight of 3.667 times the original carbon molecule. So when we have carbon created through photosynthesis in dry wood material, and we let it degrade back into the air, evaporate essentially, if we took a different approach of managing that material, we could use the photosynthesis as a primary means of sequestration.
Wanting to move on?
Yes, next, please. Okay, the carbon cycle, real quickly, for those of you that don't know, the annual global uptake, or the amount of photosynthesis plus other sequestration of CO2 from the atmosphere, is about 220 billion tons. And fossil fuels, for example, only emit 36 billion tons annually into the atmosphere. So the world is very easily able to take the emissions from fossil fuels. The problem is the natural emissions globally. The largest emitter of CO2 is the world itself, and dead and dying biomass. So our largest emitter is biomass. We should also look at ways, if we're going to work on reducing emissions through fossil fuels, we should also look at forest management techniques to reduce emissions, natural emissions. You can see from the figure on the right, here in Houston, we're uniquely geographically located next to what I call America's carbon sucking asset, being the American South, with millions of acres of timber farms.
To move on?
Next slide, please.
Yeah, by the way, one comment, if you can try to speak a little louder or perhaps get a little closer to your mic there.
Okay, thank you, Alan. Is this better?
Yep, yeah, that's strong. Good, thanks.
Okay, and this is from Professor Zhang's research on the matter. You can see the lifetime of buried wood is much longer than the lifetime of CO2 in the atmosphere. CO2 does stay in the atmosphere for thousands of years, but the majority of it will sink into the ocean, or otherwise float down into the natural sinks, carbon sinks of the earth within a few hundred years. So buried wood is one way that we can bridge the gap towards a time when CO2 levels are lower. On the right, you can see that so recently, this is from our Facebook site, a tree was unearthed in New Zealand and carbon dated to be about 45,000 years old. And the condition of the wood doesn't look great, but you can see that it's still wood. Next slide, please. Another example of sequestration of wood is the existence of Venice. Venice is built on wood beams that are in an anaerobic condition, and therefore there is essentially no emissions. And so the wood in the Venice case is replaced by the lagoon minerals that are floating around, and you know, this is long-term sequestration for that wood. Another example is some wood found at an old harbor in Boston, and they are actually repurposing this 300- and 400-year-old wood. So wood burial is something that we do accidentally. Nature does it. And the question then is whether we can do this on a commercial scale with the new carbon pricing that we have available in an economic way. Next slide, please. There are three potential sources, or large industrial sources, of wood and biomass. And these are, number one, when forest is clear cut for timber, there is approximately 15 to 20% that is left over. They call this slash. And this slash, the production rate is about 15 to 20 tons per acre. So our first place that we're going to look is slash. There are two other areas where we can find wood products as a result of at the sawmill. And the third one would be end-use products, old chairs, old wood, down Allen Street after Hurricane Harvey. And all of these different species of woods are going to have different issues that we're going to have to deal with, but they are all potential sequestration components. Next slide, please. As to the slash that I mentioned, when timberland is clear cut, basically the sawmills are unable to take a tree that has less than a certain diameter. And with the recent timber prices really collapsing due to the COVID-19 situation, the sawmills are taking less and less of what is the unmerchantable tip. So all the limbs are cut off, the tip is cut off, and that's generally strewn back to the property and used as a type of mulch. We believe that we can use this mulch and bury it, taking advantage of the new carbon pricing. Next slide, please. In our case, we've chosen two locations to begin in East Texas, in the heart of the Texas timber industry. We're partners with American Forest Management, who's the largest forest management company in the U.S. Next slide, please. There are widely known data points from the Department of Agriculture on how much biomass is created and how much slash is created. This slide is simply to show how, you know, that these slash numbers are well known. And most estimates are around 5 to 20 tons of essentially slash per acre. Next slide, please. You can see from this slide that there is a correlation between the diameter of a tree and its weight, generally on a species by species basis. And the species of tree that we're looking at is the Pinus taeta, the pine loblolly pine tree. These are very fast growing trees. A DBH, or diameter at breast height, of about 12 inches gets you close to 1 ton of green weight, and then the conversion from green wet weight to CO2 is you cut it in half. So if you have a 10-pound branch in your yard that's newly cut off of an oak tree, about 50% of that branch is going to be water. About 50% of the remainder of that will be carbon. And using the 3.667 carbon to CO2 connection, we come up with about 91%. So if you have a 10-pound branch in your yard that's freshly cut, that's about 9.1 pounds of CO2. So I think when you start thinking about it that way, you see that we have the potential to scale this idea in a lot of areas of our life. Next slide, please. Focusing in on this 12 to 14 inch DBH, because and I'll show you from some of the other slides that the trees get to about this size when they're harvested, so they're growing fastest until they get to the 12 to 14, and then the time for it to grow larger than that is usually not worth it for a few different reasons. But the density of planting these loblolly pine trees, usually around 700 to 800 per acre, and a good forest manager will hope that 300 of those will survive per acre. 300 trees with a 12 to 14 DBH, each one weighing or having approximately 1 ton of carbon. So you can see from 1 acre of land, you would have 300 tons of CO2. So how long does it take to get 300 tons of CO2? Next slide, please. This slide is simply to show that the moisture content is a big part of the calculations, and it changes based on the weather and the time of the year. Next slide, please. Here we talk about pulpwood prices, and one of the really interesting things about the market right now, which is a little bit in free fall, is that pulpwood prices, which is wood used generally for paper construction and other bags, cardboard, etc. The market is already, with the current carbon pricing, could be pricing out pulpwood. In other words, it could make more sense to use pulpwood or compete with the existing industries that use pulpwood and simply bury or sequester the pulpwood. Next slide, please. Here we see, this is from the U.S. Department of Agriculture. We see a chart which shows how many tons of carbon per hectare, which is approximately, I think, 2.47 acres in a hectare. But you can see, and then if we do our conversions here, this is a very conservative, these are conservative numbers, but you can see that the growth rate is pretty strong up until year 25, and then it levels out for an average stand. So you can calculate how much carbon you're growing, how much your standing stock of carbon is. Now, after about year 40, the forest is really, the DBHs are still increasing, but the amount of carbon being sequestered is less economic than it is at year 15 or 20, which is one of the things I think should be debated or understood a little bit better, and there's some new research coming out on this. We all love our forests, and we love the ecosystems that our forests provide. But one thing that we need to study and understand is that very old forests are like old folks' home for trees. And these trees might have plenty of wildlife, but they become net emitters of methane and CO2. A new study by the University of Delaware shows that methane emissions from tree trunks can be substantial. And methane, of course, is 25 times stronger than CO2 as a greenhouse gas. So, whereas the Kyoto Accords sets aside certain land for permanent forests, a permanent forest is not a sequesterer of carbon. A permanent forest is essentially a standing stock of the maximum amount of carbon that can be grown, and then becomes a net emitter of methane and CO2. So what could we do to manage these forests? Well, we could take out the old trees and bury them and let the new trees grow up. Already a lot of carbon management is being done in the Midwest with regards to the organic content of the soils using no-till processes. Next slide, please. Okay, to answer the question I brought up a few minutes ago, which is how long does it take a loblolly pine tree to get to a 12-inch DBH? And the answer is about 21 years. And you can look, there's various studies done on this. But so 20 years, if we planted 700 trees per acre, and then we're left with 300 or 400 good ones, that would be approximately 400 tons of CO2 per acre over essentially a 20-year time period. And as far as I know, this does not account for fertilization. So doing the numbers, 20 years to create 400 tons means that we could do, or we can essentially create a carbon stock of 20 tons per year per acre. That's substantial, considering that the average American emits 16 tons of carbon dioxide per year. So 1 acre can offset, if managed properly, 1 acre can offset 1 U.S. citizen. And the amount of, we have approximately 325 million U.S. citizens and 1.75 billion acres available in both farming and timber land. So it is theoretically possible that through effective management of our land, the country could become carbon neutral or carbon negative simply by using photosynthesis. Next slide, please. This is a study done by a different professor, Zhang, not Zing, and this shows a control group of fertilized, I think 9-year-old pine trees versus non-fertilized. And you can see the lower figure showing the volume. It looks like approximately 25%, maybe 30% increase in volume, and I believe that there's a close correlation between volume and weight. So that number of 20 tons per year, we might have some upside to that if we're able to use fertilizer. Next slide, please. All right, assessing the carbon market, and right now it's a hodgepodge of different governmental organizations. There is a voluntary market where private companies and several of our leading oil and gas companies want to offset their operations emissions, not the content of the actual oil or gas that they're finding, but the operations that they conduct. They want to be carbon neutral. And on this voluntary market, carbon dioxide is going at around $12 per metric ton. The carbon markets are in some cases stackable. The new 45Q credit that's available through the IRS is $32.50. So whereas this method that I'm talking about may have not been economic at $12, it is now, with the stackable 45Q credit, if you can use it, very profitable. Generally, timber operations cost around $14 per ton. There's some upside to this pricing through some of the initiatives that are being used in California, such as the low carbon fuel standard, which essentially forces the retail drivers of, and buyers of gasoline to make the gasoline or carbon neutral, or to some extent carbon neutral. Next slide, please. I think this gets into, how do we get carbon credits? It's always the same. Carbon credits have to pass what I call triple MRV. The methodology has to be approved. The measurement has to be consistent. The monitoring must be ongoing and consistent with the methodology. There must be reporting to the correct agencies, and then there is independent verification. Almost the ACR, the American Carbon Registry, uses this triple MRV, as well as the EPA. So our plan is to work with all of those agencies to develop triple MRV, and Professor Zhang is also helping us with that. Next slide, please.
And I should mention, Chris, we're pretty much at the end of our time, so we're pretty much at the end here, right?
Okay. Yeah, we are at the end, and I think we can open it up to any questions. I guess tying it back in with Hurricane Harvey, there is an opportunity to, in times of these hurricanes that knock out thousands of acres of dead wood, to bury that wood. That would be a perfect opportunity for example, the fires that occurred off of Highway 71 a few years ago, to take that burnt and emitting wood that is emitting lots of methane and turning that into a net sequestration. I have a couple of chat questions here. One of them is, how deep must the wood be buried? And that is actually, that's the pit design. This slide right here, this was done by our KDW, a construction company here in Houston that's partnering with us on designing these pits. And this is called our mega pit. So in this case, it's actually a big hill, and we have a clay cap. These pits can only be constructed in areas where the clays meet certain requirements, and that's the job of our soil engineer. But essentially, the requirement is always the same. You have to have a secure geological state. And we also have designed what's a gas collection system, which is pipes that go into the reservoir of the wood and create low pressure areas that take out the methane. So, so are there any other questions? How deep must it be buried? I think that's an economics question. Professor Zhang wanted a deeper burial. I think the economics are pushing us towards more shallow burial. another question regarding the problem of permanent forests. Can we encourage timber harvesting with burying / via carbon pricing? And I think the answer to that is yes. I know there's some other people in California that are trying to do this. Mr. Hoffmeister was talking about a person that wanted to take over the California Department of Forests and actively manage those forests, but ran into considerable pushback from Greenpeace and some other environmental groups. So I think once carbon pricing, as it increases, and the numbers that I showed you on that prior slide of $32.50 are going up to $70 by 2040 or 2045. So what is barely profitable now is going to be extremely profitable as we go forward. But the idea is to use photosynthesis and to pick the lowest hanging fruit when utilizing this new carbon market.
Very good. Thanks so much, Chris. We are out of time. There are several other questions coming in about other emissions associated with this and questions about pricing. But at this point, we do have to stop because we have past 5 o'clock, which was our end time. Did just want to just briefly here, we've got your contact information if anyone is interested in getting back and perhaps dealing with you more specifically on some of these things.
Yeah, I'm more than happy to speak with anybody. You can follow us on Facebook. We've got a website here, or feel free to shoot me an email.
Very good. Thank you so much, Chris. And so with that, I would thank you for joining our webinar. I should also mention that on May 7th, which should be a Thursday, we are scheduled for our water forum. Now, this also is scheduled to co-locate with the AICHE dinner meeting. I think nothing has officially been decided on whether there will be an in-person meeting or not. Most likely, given current circumstances, it will be a no, in which case we will have the water forum as a webinar as well. So either way, though, we look forward to seeing you on May 7th for our water forum. And with that, I bring this session to a close. And thank you once again for joining us.